This week on Quality Digest Live, Paula Oddy of Intertek offers us a refresher course on transitioning to ISO 9001 2015.
That's right, plus a look at the future of manufacturing. That and more when we come back.
This week's sponsor of Quality Digest Live is Olympus, specializing in easy-to-use digital microscope solutions that provide the measurements and images you need.
Welcome back to Quality Digest Live for November 11th, 2016. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest Editor-in-Chief, Dirk Ducharme.
Did I write publisher on that?
Yes, you did.
Wow.
I got a promotion. I didn't even know it. I'm publisher now.
But you said it right. That was really impressive, Dirk.
Wow.
Ad living off the prompter. Very nicely done, Dirk.
There we go.
That's good. Good job.
All right. Well, every year, at least I think it's every year, research analyst Gartner Incorporated announced their top 10 strategic technology trends. Top 10 strategic technology trends.
Very well sped.
What they define a strategic technology trend as one with a substantial disruptive potential that is just beginning to break out of an emerging state, and into broader use. They're all pretty interesting, and you can see them all if you follow the article link in the player page, but there were a few I wanted to call out because they really kind of leapt out at me because I think they have probably the most applicability to, let's say, manufacturing, a lot of an industry that we cover a lot. So first up was artificial intelligence, or AI, and advanced machine learning. And this is the technology that allows machines to learn, in essence. And these employ more than your traditional rule-based algorithms, if this, then do that. These are systems that really understand, learn, predict, adapt, and potentially operate autonomously. Now, most of us are familiar with, let's say, self-driving cars, which are supposedly supposed to kind of learn the more they're driven. And but even in our industry, manufacturing, we are seeing this technology used for collaborative robots, or cobots as they are sometimes called. These are robots that actually learn on the fly by observing what humans do by working side by side with them. They actually monitor our motions and adapt to them. And there's a lot of work being done on this, and you'll see more of this in the future. Number 2 in the top trends from Gartner, intelligent things. Now, this is really kind of an extension of the AI and advanced machine learning that I just mentioned. But this drills down into smaller, traditionally dumb devices, connected devices, what we've been calling, let's say, the Internet of Things. So these are intelligent things that refer to these physical things that go beyond the execution of rigid programming models or behaviors. And instead, they deliver more advanced behavior and interact more naturally with their surroundings and with people. So think of the way more and more apps on your smartphone interact with you and maybe tell you when you're driving down the road that, oh, by the way, we know that you're interested in, geeky technology, gadgets, so there's a Best Buy coming up, this type of thing, right? So now, as the proliferation of intelligent things such as drones and autonomous vehicles and smart appliances continue to grow, Gartner anticipates a shift from standalone intelligent things to collaborative intelligent things. Think about that. All of your little smart devices talking to each other. Maybe your stove talking to your washing machine. Hey, you just spilled something on your shirt, you're going to need to soak that.
Yeah.
Or your fridge talking to your car. By the way, we happen to know that you're out of milk and there's a Safeway coming up, right?
Go grab it, yeah.
Yeah, so number 3 in the top trends, virtual and augmented reality. And boy, are we seeing a lot going on with that, even in manufacturing. Yeah. Immersive technologies such as virtual reality and augmented reality transform the way individuals interact with one another and with the software systems. We just saw a fantastic virtual reality system for training the other day. The demo we watched actually showed a person being trained to perform a physical task. In this case, it was changing tires on a car. He actually went through the motions of changing tires, picking up the tire, picking up wrenches and the like, and was tracked and corrected on the fly as he changed the tires on a car that wasn't even there. It was really pretty darn funny to watch. I mean, this guy was he was picking up a tire, putting it on the car, picking up a wrench, putting the tires on as the software tracked him. What he saw through his goggles was like he was actually doing this. If you actually watched him, it's like air mechanic, right? I mean, it was really crazy. Yeah. But this is being used for training purposes. Yeah. Seen a lot of that. Finally, the digital twin. We've been hearing a lot about digital twins, and the term is used in a lot of ways, but in essence, it is simply the modeling or overlay of an existing model of real-world data. So you might have, let's say, a CAD model of an object, car engine, for instance. And sensors in the car engine, the actual car engine, report information on the engine back to that digital model in real time so that the digital model can now show what is really happening in the actual engine. So it's a digital twin of the engine, not just a 3D rendering. Gartner says that within 3 to 5 years, hundreds of millions of things will be represented by digital twins. Organizations are going to use these to proactively repair and plan for equipment service, to plan for manufacturing processes, to operate factories or predict equipment failure. As such, digital twins will eventually become proxies for the combination of skilled individuals and traditional monitoring devices and controls. So if you want to read more all about these 10 tech trends, of which we've just covered 4, you can click on the link underneath the player page below and kind of geek out to your heart's content.
What strikes me about that is this idea that technology and human interaction are coming together and are not. You've talked about this on the show in the past that in the past days, let's say, of robotics, there had to be very much of a separation between robots working in areas discrete from people working in areas because it was dangerous for people to be around robots. But the technology now, the sensitivity of it now is such that they can coordinate and collaborate in real tight spaces, and there's not a danger anymore. Cobots, which really leads to a lot of interesting possibilities for a lot of these.
And we're going to talk about one of those a little later on too.
Cool, excellent, good stuff. Thanks, Dirk. All right, well, if you're listening to the show, I think there's a pretty good chance that you've either worked directly with ISO 9001 or you at least understand the basic importance of the standard to help foster organizational improvement. I think that's really important. The current version, ISO 9001 2015, has been out now for more than a year. It's amazing that it's been, it's been like 14 months. And users are slowly, very slowly, in many cases, migrating their way over from the 2008 version. In truth, now you have until the summer of 2018 to complete the transition and remain registered. But the new language in this revision contains some fairly significant changes. So I think it would probably safe to say that it would behoove many of you out there to start on that process early if you haven't already. We're presenting a very informational webinar on this very topic titled ISO 9001 2015 Revision Refresher this coming Thursday, November 17th at 2 p.m. Eastern, 11 a.m. Pacific. The presenter on that's actually going to be David Mule of Intertek. He's sitting in actually for our guest on the show, Paula Oddy, and Paula is the Technical and QMS Manager at Intertek's Business Assurance Group. So Paula's going to join us now to chat with us about the transition to ISO 9001 2015. Paula, welcome back to the show.
Thank you. Thank you for having me on, and it's an exciting time to talk about the technology you guys were talking about and how and why the 9001 2015 changed just because of that reason. So that's good lead-in. Thank you.
Perfect synergy right there. Well, let's get into it. I mean, I alluded to it in my introduction, but maybe you can expand on it a little bit. There's some pretty major changes in the terminology of this version of ISO 9001. So in your considered opinion, what are the most critical ones and what do they mean for users seeking to implement the standard?
I'm going to start with the first one. The new standard talks about documented information. And the documented information gives companies now the opportunity to do documents the way they need to do them. If you remember in the 9001 2008, It said you need this many procedures, you need this many records, and it was more strict on you must do it. The new standard says documented information, however you maintain it, your operating system, however your own procedures work for your organization will work. Okay, so geez, what a concept that it's actually making business sense. So documented information is one that's used in the whole standard. It's replacing everything that had to do with a document, whether it was quality planning, record, procedure, etc. Okay, so it's called documented information, flexibility. That's the two things to remember. Applicability replaces exclusion. I think it's worthwhile to spend a little time on that. Exclusions in the standard used to be, yeah, well, I can just go ahead and exclude this, right? Applicability now holds us to be a little accountable, say it no longer applies to me because it does not affect my product and service. So it's not just an offering to exclude. I need to justify why perhaps design is not applicable to my organization. So applicability is another one. Organizational knowledge is also one that jumps into mind. Organizational knowledge in the new standard is raising the bar. One of them that I think is really near and dear, especially I will say to the auditors' hearts, is preserving knowledge. I'm sure many organizations out there have many people that have worked for many years that, like all of us, have a lot of things in our heads. And now we need to come up with a path to preserve that knowledge. And it will be challenging to organizations, but the value down the road is there. So organizational knowledge would be another one. Risk-based thinking. Risk-based thinking has always been in the standard as preventative. Preventative action, if we all recall, in the old standard was a certain section. And everybody rushed to the end of the day, what preventative did I did before the ISO guy gets here? Risk-based thinking now is throughout the whole standard. And it forces us to think about each process, what the risk is. In the early stages, in our planning what the risks are, it's going throughout the whole standard instead of one little piece where we're talking about preventative action. That's the big gain to this new standard. This is really my excitement in the new standard. Interested parties need to be determined. Interested parties are not anymore just, customers. We love them, of course we do. Suppliers, but interested parties can be to employees. It could be bankers. It could be the union. We need to understand who our interested parties are, as we need to capture that. And last but not least is context of the organization. Context of the organization is in the first part of the standard, and it helps, it has the organization actually identify their internal issues and their external issues. The standard actually uses the term issues, but you could think about it as influences, because it's another one of those risk-based thinking thoughts that we have to come up with. In other words, what internal influences affect an organization? Well, it might be aging employees, it might be the environment, whatever the case is. But we do that for both internal and external. Okay, so when we get down into the program a little bit, we'll understand where that comes into play, especially to help our service organizations. So when they're not just making a product up front from the context of the organization, they can identify what's important to them in a service and what influences their organization.
Hey, Paula, the language of the standard has been I believe, streamlined and simplified and clarified in many spots. For example, the use of the term goods and services instead of product. How do you think the new language improves the usability of the standard, or does it?
It absolutely does. So, and that's a great question. So, goods and services is really what was needed. In the old standard, everything was based on a product, and there was this little bitty definition that said products mean services. But at the end of the day, service industries simply do not create a product that we think about. So what happened is people were following this based on the fact that they were a manufacturing organization. Service organizations, hospitals, etc., were like, that doesn't apply to me. So what the ISO world did is said, we need to bring in the service industry. And that was one of the reasons, one of the biggest reasons for the 2015 change was not just technology and global economy, but it's the fact that there's so many service operations out there.
Well, Paula, you know, this standard, of course, has changed a lot as we've been talking about. So, in your opinion, what did users do if their QMS was moving along perfectly nicely in compliance with the 2008 version? I mean, for example, this is a big change that a lot of people are chattering about. What if somebody likes having, say, management representative? There's no call for management representative in the 2015 version, but what does somebody do if they like having a management representative?
Well, there you go, and that's please don't fire your management reps. Okay, so the new standard is just getting leadership engaged. Okay, it was always intended that top management was involved, but now there's direct leadership. They must understand process approach, risk-based thinking, all of the things. It's important the management rep has the responsibility and authority. The thing that cannot happen is when anybody goes for an audit, it's not just the good old quality guy anymore, okay? It might be very well that he's the guy that's leading it, but it needs to be showing that it encompasses the whole organization and they're living and breathing the standard. So that's one of the things in what you'll see in David's presentation is please don't fire your management reps, but please do make sure that they understand what the context is.
Well, Paula Oddy, thank you again for joining us today. As you just referenced there again at the end of our interview, David Muell is going to be presenting on this very topic on your behalf this Thursday coming up on the 17th of November. The webinar is coming up right there, ISO 9001 2015, Revision Refresher, live webinar on the 17th, Thursday, 2 p.m. Eastern, 11 a.m. Pacific. Our good friends at Intertek, along with Dirk, is going to be hosting, and David Muell is going to be presenting from Intertek, so be sure to register for that one. Paula Oddy, thank you again for joining us and giving us a little bit of insight into the language of the new 2015 version of ISO 9001 2015.
And thank you, gentlemen.
We'll talk to you soon.
Mm-hmm.
All right, now we have remember at the top of the show, we talked about Gartner's top 10 technology trends. Coincidentally, Andy Henderson, an industry analyst at GE Digital, had an interesting 3-part series called A Perspective of the Manufacturing Future, in which he takes a look at how the use of existing and emerging technologies, such as some of those we just talked about, will impact tomorrow's manufacturing. And really, this is one person or companies, GE in this case, prognostications about what the future of manufacturing holds for us in terms of technology. So let's look at machining centers, for instance. So in the case of cutting tools, a lot of you have cutting tools, you have machining centers, CNCs and so forth. So Henderson says that, in the case of cutting tools, where can already be monitored on the fly. But he's saying that it's going to be possible in the future that worn tools will be replaced by robots. You're going to have tool wear monitoring, which is actually going on now. A lot of machining centers use laser scanning or video scanning tools to look at their tools, but now we're talking about once it's been determined that those tools are due for either sharpening or refurbishing or replacement. Rather than a human being doing that, a robot will actually come over to the machine, extract the tool, put a new tool in place, and either dispose of or somehow disposition the tool that was just removed. So it takes kind of the human out of that. Kind of actually allows for lights out manufacturing, really. So data from monitoring the tools could be used to predict the life of the tool. It could be used to determine if tool wear is caused by some problem with the machine itself. And again, you could automate the preventative maintenance process using data collected on the fly from cutting tools. So again, what we're saying here is that all of this data, which in a lot of machining centers already is being collected, but now rather than just being this data being collected and then a human being coming in, interpreting the data, and then telling somebody, a maintenance person or whatever operator to go out and do something, that a lot of this is going to be automated in the future. This data is going to come in, it's going to be processed, and some sort of automated system is now going to deal with this data.
So we heard about this at IMTS as well. I mean,
we did hear about this. We had a great demo from Siemens.
Exactly. So this is definitely, this isn't weird future way out there stuff. This is stuff that's definitely practical and happening and moving
and
in that direction.
In fact, part of what Siemens was showing was really advanced machine learning and AI and augmented reality. In fact, where a demo we saw from Siemens, they had sensors on machine tools and machining operations that fed back into a 3D model.
Right.
It was digital twins, right? They had a digital twin of a machining operation, so that what you saw in the CAD representation of that machining operation, what was actually going on in the real machine. So again, you had a digital twin. And this is kind of, then they could feed that forward or feed it back into the process to change the process that was going on in order to optimize that
workflow in real time. Exactly right.
Again, this isn't pie in the sky. This stuff is happening. So and now another thing that could happen is all that real time tool life data from that operation could be used as feedback to AI systems that we just mentioned, and you could automatically adjust machine process parameters to optimize not just the machine process for an overall process, but optimize the machining costs of each individual part. Suppose you have a machining center that works on different parts. Well, rather than just optimize your machining center, you optimize your process for each individual part, allowing you to produce that part at a lower cost while still maintaining quality levels. So we're talking about individual parts, not an entire process that might encompass multiple parts. So that you can see where the value would be in that.
Exactly.
Henderson also, getting away from, let's say, the physical machining process, Henderson also talks about data silos and how in the future those silos are going to go away. I mean, think about how often there is a disconnect between sales and manufacturing and your CRM, your customer monitoring and reporting systems, diagnostics and services and product development. Each of those functions or departments often work with complete disregard, deliberate or otherwise, to the other. And yet think about the connection that there exists today between customer monitoring and reporting and design, or customer reporting and manufacturing. How about between sales and manufacturing? We know about the connection there. Or how about this? How about human resources in manufacturing? What happens when a person's sick or there's a planned department meeting? Is that information automatically communicated to schedulers and project planners? I mean, I can't tell you how often this happens, and you know it yourself. Somebody's planned a big company-wide meeting but never told anybody ahead of time there's going to be a manufacturing shutdown, and they don't know until the night before, oh, by the way, we're shutting down manufacturing. I hope you can catch up later.
Thanks for letting me know.
Thanks for letting me know. In the future, writes Henderson, all this data is going to be shared, and the actions are going to be automated. Field failures may trigger actions in manufacturing design. Supply chain failures will trigger actions in purchasing and production. He gives a really good example. He says, suppose there's a component failure on a product at a customer site. That's going to be linked in the future to manufacturers' equipment and personnel inside of a shop. Who actually built that product? The supplier who supplied the raw material to that product. The quality checks throughout the manufacturing process for that particular product or that specific device. The design of the product, the analysis and testing that went into the design, the customer order that drove the product configuration. Imagine how much easier it's going to be to do root cause analysis and mitigation when all the data that went into that one specific device is all available in one place and in the proper context for the person who's reviewing it. And like I just said, this isn't pie in the sky stuff. Neither was the Machine Center example. The technology and the software is there, and both hardware and software, and companies are offering some or all of these solutions right now today. I mean, it really just boils down to looking at our entire manufacturing process in a different way, rather than siloed operations in a more holistic viewpoint. You know, how can we leverage technology, software, and hardware so that all of this data we are collecting can be used to inform or automate our systems? I mean, just as fascinating stuff, and this isn't decades off. This is really years off. A lot of this.
It's really in a sense happening
and
now.
A lot of it is happening. Like I said, we mentioned Siemens.
Yeah,
Hexagon's doing the same thing.
Yeah, I mean, these things aren't. These things don't happen usually in huge breakthrough moments where all of a sudden, like now, wow, we're doing this.
No, it's just slowly.
It's slow evolution of this stuff as it changes and as it evolves, and it becomes the reality before you even know it sometimes,
right.
You know? So we go to an IMTS in 2016 and we see these things, and we talk to people and we read articles like this, and we go to IMTS in 2018 and now it's just reality. I mean, it's just happening, and it happened over the course of dozens of little shifts of that consciousness over the course of those 2 years. Fascinating stuff. And this industry is this industry is where it's happening. You know, if you think about it, I mean, if you think about industry in general, this is where the action is right now.
And also, I mean, just we talk about getting youth interested in manufacturing. Just, and we say it over and over. It isn't just nuts and bolts anymore. I mean, it's super high tech stuff going on, and they need technology people. They need. I mean, just it's amazing what's going on.
See,
in manufacturing.
the idea of bringing back jobs that are turning screws is really missing the big picture. The idea is to have jobs, start companies that involve this as the key differentiator, and bring people here that want to do that work. That's really important, I think, and that's the missing piece of all this. Great stuff, George. Thanks again. All right, well, our good friend Bruce Hamilton recently brought us his latest article titled Doormats. Doormats, that's right, which we ran in Tuesday's issue of Quality Digest Daily. There it is. A little bit of a cryptic title, I think.
I'm not a doormat.
Without reading the kicker there. So who are these doormats? Publishers are generally considered to be doormats. Editors-in-chief? No. In this case, that's not what he's talking about. The doormats that Hamilton is speaking about here turn out to be design engineers. Imagine that. Now, that's not normally a class of employee that I would think of as being walked all over. But, you know, as Hamilton explains it in the piece, many organizations really don't do a very good job of optimizing the critically important design work that lean operations in particular demand. Of course, remember, Bruce is taking this from a lean perspective. He's looking at lean manufacturing, and when you look at it from that perspective, and as we'll explain here, you start to see why it's so important to have respect for your engineers and have the engineers understand what they need to do as part of the broader operation. So, the feeling that engendered this doormat designation can best be summed up by a quote that Hamilton offers in the piece early on. As he recalls, in his career, at the beginning of his career, he and his company were adopting lean and being trained by some high-profile consultants with experience in the Toyota production system. So one of Hamilton's engineers exclaimed during some of this training, well, when things go wrong, production just blames us, right? They always blame us. And actually, in truth, part of that feeling was driven by those Japanese consultants. They didn't have a particularly high respect in many cases for engineers, as Bruce indicates, and they didn't hide that contempt. And well, in truth, they didn't hide their contempt for lazy engineers, for lazy engineering that failed to take into account the realities of the production and assembly functions in their organization. See,
aforementioned silos.
The aforementioned silos. See, what you have to understand, again, to get back to lean, from a lean perspective, waste, which is introduced into a process very early in the value stream, is really the worst waste of all, because it causes cascading wastes further along the process. Having to redesign something at the assembly level represents a failure to properly plan, which falls directly, of course, at the feet of engineers. So now we start to understand why an engineer, especially one in an organization just beginning to embrace lean, might feel a little bit like a doormat, and maybe it's for a certain amount of cause, at least in certain situations, as Bruce describes. The next question, of course, is how those engineers can get off the floor. And see what I did there?
That's nice.
How those engineers can get off the floor and start adding value instead of waste to the processes that they're involved with. Hamilton has a couple of simple suggestions, I think, that address this nicely. One thing he says is that engineers have far too much work in process, far too much WIP. According to a study quoted by Hamilton here, the optimal number of projects that a design engineer should have going on at any one time is 2. 2 projects at any one time.
Yeah.
That's not the reality in many of these organizations, as I understand from reading some of Bruce's work. Many organizations, designers typically have double, triple that amount of projects flying around them at any given time, which is obviously not good.
Software engineers as well.
Yeah,
probably
exactly.
Probably even more so.
Yeah, than that.
Yeah.
Another issue that arises it comes from a typical engineering mindset. Most designers, no surprise there, they like to create their own new designs rather than work off of, and hopefully improve maybe, someone else's existing ones. Yet this attitude needlessly adds complexity and usually results in wasted time and or hastily prepared, suboptimal designs delivered to production. You know, I mean, you're building something that may be competitive with something that already exists, and you're not utilizing what's already there and improving it, because that's not as much fun as launching your own things. But that's really suboptimizing the process. And a related issue to this is the way that designers are generally housed within the organization. I mean, many times they're in cubicles and they're separated from one another, and that often suits the independent nature of the typical engineer, but it restricts the free flow of information and ideas. And one of the quotes we had in this article was, it also restricts the idea that not only is there free flow of idea between them, but between others in the organization, across all points of the organization. That's a key one too. So, you know, people with different viewpoints and perspectives and unique talents won't get together and lead to tighter designs. And the system in many organizations just isn't fostered to set up that kind of result. So the idea of engineers as doormats, I think, driven by the fact that design is an all too frequent source of tremendous waste, is really caused by these combinations of overarching system flaws and individual personality quirks and rather prevalent operational constraints too. Design engineers don't have to be the doormats of the lean world, but I think unless those factors are understood and they're overcome, it's inevitable they're going to be. And you mentioned you've seen this too. You've seen this play out. You know the issues that engineering and poor engineering, lazy engineering can have in terms of interfacing with production down the line. And that cascading waste is deadly in a lean environment. You know?
Well, I mean, it maybe not as prevalent now as it used to be, but I mean, it's not unusual for engineers and architects to design stuff that is really hard to build.
Yeah.
It's like it looks great on paper. It looks great when it's breadboarded or you know, mocked up.
Yeah.
And then all of a sudden it gets out to production. It's like, oh man, this is a nightmare.
And they weren't involved. The production people weren't involved in that process, so they don't know. And they're looking at the material specs that might be involved in that, or the tolerances, whatever. And they're like, well, I mean, we can do it, I guess, but how much time and money you got, right?
Or purchasing, you know, says, wait a minute, there's only one source for this part you want to use.
Yeah.
What happens if the source dries up and this product can't be built? You're going to have multiple sources. I mean, all sorts of stuff like that. Again, if you don't have a cross-functional view on it, you're not going to ever get to. So that's what Bruce is talking about here, and he always has good articles. So that's a good one. Check out that article again below the player page and read up about it. So that's a good article there. All right, well, that's our show for this week. But before we close, I think we'd like to offer our thanks to this week's sponsor, Olympus, offering solutions for test, measurement, inspection, and imaging instruments designed for high precision quality control and R&D. Olympus engineered solutions enhance quality and productivity in industrial markets around the world. So for more information, click on the banner ad just below or just to the right down there of this video player screen. That's right. And that is the end of this show. But don't forget the upcoming webinar, ISO 9001 2015 Revision Refresher, this coming Thursday, November 17th at 2 p.m. Eastern, 11 a.m. Pacific, sponsored by Intertek. Paula Oddy, who we just had on the show. She is not going to be. She was going to be.
She's going to miss it. She had a conflict, but David Mueller, her colleague,
that's right,
is going to be presenting it. David's a great presenter too, so check that one out next Thursday.
Yeah, that's right. And to register, you can just actually on the player page down below, there is a link to the registration page for the webinar. Just click on that, and you can go out and sign up for today's webinar. As usual, they're always free.
Or check out your email inbox, and you'll find it there too.
That's it. So that's it for today's webinar. And thanks again to Paula Oddy for joining us. Right. And you all have a great weekend.
Yep. We'll see you next week.
So long.
Bye.
She was thorough.